Good evening, everybody. Welcome to the week 7 tutorial session of bioreactor design and analysis lecture. So, um, so I hope you have all completed your week 8 assignments. Um, so so this class is about your um, week 7 lecture, which includes half of the sterilization and your scale up bioreactor, scale up theory and scale up of the bioreactor. So let's wait for a few more minutes and then start with the questions. So let's start with the first question. So I hope you are remembering what was taught on your week 7. It's about sterilization. And the first question is, in batch sterilization, it is difficult to get ideal temperature time profile. It's a true or false. Please take a few minutes and go through the question and answer whether it is true or false. I hope you have learned about that you have learned batch and continuous sterilization and know the difference between the two. So the answer for this question would be true, because in batch sterilization it is indeed difficult to get the ideal temperature time profile. So the question number 2 is, with the increase of superficial air velocity, the collection efficiency of impaction decreases, whereas collection efficiency of diffusion increases. Whether the statement is true or false. So what is the answer? So here the answer would be false. So in case of ungassed nutrient fluids, the power required for laminar flow is independent of the viscosity of the fluid, but proportional to the fluid density. What is the answer? True or false? So in case of your ungassed Newtonian fluids, what happens whether the power required is uh, for the laminar flow is independent of the viscosity or dependent of the viscosity. What is the answer? What in case of laminar flow it is? If there is no density coming into picture, so this actually false. So what does a successful scale-up requires? It requires geometrical similarity only, dynamic similarity only, and both geometrical and dynamic similarity. So what is the answer for this question? So the answer will be both geometric and dynamic similarity. So whatever um, both the in case of your bioreactors, both they should be geometrically and dynamically similar. Then only we can get a successful scale up. So the question number 5 is power number NP in a bioreactor is constant when the Reynolds number NRE is lesser than 10,000 or greater than 10,000. What would be the answer? Uh, you can note it as power number in a bioreactor is constant when the Reynolds number NRE is greater than or less than. What would be the answer? It's actually greater than 10,000. So let's move on to the problem. Please take 3 minutes to read the problem. It is simple problems only have taken. It's about surface sterilization. It's about sterilization. Um, so I would read a question and then we will wait for a few minutes and then start solving the problem. So question number 6 is a large-scale bioreactor with 10,000 liter of complex medium containing 10 power 4 spores liter per inverse is being sterilized. So your del factor value for the system is 15 and using the following information which is your gas constant is 1.987 calories mole inverse Kelvin inverse and 0 degree Celsius is equal to given as 273.15 Kelvin. So you have to determine the probability of successful sterilization and also you have to determine the probability of unsuccessful sterilization. So please take few minutes and read the problem completely, and then we will start solving the problem. So let's start writing down our given values. So what is given? The volume is 10,000 liter and spores is 4 per liter. Your del factor, which is KD into T, is equal to 50. So we have to calculate your probability of successful sterilization and probability of unsuccessful sterilization. So let's start solving the problem. So to calculate the total number of spores, we have to multiply your number of spores provided into your volume of the reactor. So the total number of spores would be 10 power of how many? 10 power of 8 spores. And your del factor, which is KDT, del factor is 50. So here, if you assume that all survival spells or spores are identical, and the probability of extinction of the total population are P of P naught Ts. So I hope you remember that. Is given by what? It is 1 minus P of T, the whole power of minus T. Is the formula. So there, this is the probability that an individual cell viable at time t. And N naught, you know, it is number of individual cells initially present. So if we assume first order, assume that then P of t is equal to power of minus P dt. Then the equation becomes P naught t is equal to 1 minus e power of minus K t, t the whole power of n naught. Okay. So if we substitute, we will be able to calculate the probability of successful sterilization. Means this this P naught T is actually probability of extinction, means killing of all of total population. So if we calculate this probability of extinction of total population spores, that means that you have already killed all the spores. Means it is the probability of successful sterilization, right? So let's substitute the values we know. So we know that KD into D, which is the del factor, is 15, and N naught value we just found it is 10 power 8, and we'll just substitute it and see. So P naught is equal to 1 minus e power of minus 15, the whole power of 10 power 8. So um, please solve this and tell me the answer. I'll wait 2 minutes and please take the time to solve it and give me the answer. So what would be the answer? So it would be around 5 point, I got around 5.8 into 10 power of minus 15. So we have to solve it like this, but I will be able to get it. So this is P, which is the probability of, so this answer is the probability of extinction of spores, which will be equivalent to probability of successful sterilization. Right. So this is for your question A. So how do you calculate the question B? Which is probability of unsuccessful sterilization. 1 minus of your probability of successful sterilization, right? So 1 minus of your P naught T is unsuccessful sterilization. So 1 minus 5.8 into 10 power of minus 14 would be, sorry. So the answer will be what? It will be somewhere around 0.999. So keeps on going, right? So it would be, we can consider this approximately one. So the probability of unsuccessful sterilization is 1. So this would be the answer. So let's take few minutes to go to the next problem. Take few minutes to read the problem, and then we will start solving it. I hope it is a very simple problem. It's a very simple problem. You can solve it easily. So let me start reading it. After that, we will take few minutes break and then start solving the problem. So the question number 7 is: media is to be batch sterilized in a 200-liter fermenter before it is used to grow microorganisms. So using a 0.001 is the probability of an unsuccessful sterilization. So ignore the heat up and the cool down. Information is given below for Bacillus stearothermophilus spores. For the Bacillus stearothermophilus spores present in the media, the spore concentration is 1 into 10 power 8 spores per liter, and your E value is given as 67.7 kilocalories per mole. The A value is 1 into 10 power of 36.2 minute inverse. So your gas constant R is 1.987 calories per inverse mole inverse, and your 0 degrees is equal to 273 Kelvin. So determine the value of KD, and that too in terms of R inverse at 121 degrees Celsius. So how do we start solving the problem? Please note down the given values, and then we will start solving the problem in few minutes. Let's start solving a problem. So let's start writing down your given values. Given as your volume is 200 liters, the spore concentration is 10 to the power 8 spores per liter. So it means 67.7 kilocalories per mole. It is 1 into 10 power of 36.2 and the R value is 1.987. I is Kelvin inverse minus. We have to determine the value of K. So how do we, what is the formula? How do we start? So it's very simple actually. You know the Arrhenius equation. What is the Arrhenius equation? What is the Arrhenius equation? Or how do we get the value of Kd from Arrhenius equation? Sorry. Kd e power of minus t by RT. So all the values are given. You just have to substitute and then you will be able to get the answer. So let's start solving it. Your A value is 1 into 10 power of 36.2 into e power of minus, what is E? It is 67.7 kilocalorie will convert it into calories. So kilocalorie, so that's why we are adding a 10 power of 3 here. And our value is 1.987 into RT. So here everything here is in Kelvin. So to convert your degree Celsius to Kelvin, it is 121 plus 273 Kelvin. Then only put that converter. So if you start solving the problem, you will be able to get the answer. So what is the answer? Into e power of minus. Solve this portion. What will be the answer? Please solve. Plus 121 plus 273 is 294. So 2.997. Plus 110 power 36.2 into e power of minus 86.47. If you do this, what would be the answer? What is the value of e power of minus 86.47? So now we have to multiply this so that we'll get the answer. So how much is the answer? 10 power of into your 2.79 into 10 power of minus 38. That would be 0.044 to 1 minute inverse. So this is the value which you get in minute inverse. So what was asked? What was the question? You were asked to determine the value of kV in terms of hour inverse. So how do we convert minute to hours? How do you convert them? 1 minute is, sorry, 1 hour is 60 minutes, right? So you have to divide and multiply by 60. So you have to for 60. This will become how much? The KD will now become 2.64 hours. So this is the answer. So answer is KD is equal to 2.64 into 10. It is RMS. Understood? So, so we'll move to the next question, which is same stabilization question. We'll take up scalar problems in the next week. I hope you have learned the theory of scalar actually in this week 7. So please take 2 minutes to read the question. I'll also start reading the question. Then we'll start solving it in another few minutes. So the question number 8 is sterilization is being carried out in 1000 dm cube decimeter cube pilot scale vessel. The medium contains 10 power 6 organisms per centimeter cube. The probability of successful sterilization is given as 1 in 1000, which is 10 power of minus 3. So you were asked to find out determine the del factor for this probability of contamination. Del factor is what? Your KD into D. And your second question is, question B is, during the scale up, 10,000 dm cube vessel is being used with the same medium as in the previous part, the same media. So you are asked to determine the del factor for the large scale if the same probability of contamination is required. So it is a previous problem of both scale up and sterilization. So we'll start solving the problem in few minutes. Please take 2 minutes to read the question and to understand the question. Then we will start solving the problem. hope you have read the question. We'll start solving this problem. So the question is sterilization is being carried out in 10,000 decimeter cube per display vessel. The medium contains 10 power 6 organism per centimeter cube. The probability of unsuccessful sterilization is given as 1 in 1000. And the question A is to determine the del factor for this probability of contamination. And question B is to determine during the scale up in scale up in a 10,000 decimeter cube vessel with same medium as in the previous part. So you are asked to determine the del factor for the large vessel with the same probability of contamination is required. So let's start solving the problem. So the start of the sterilization in let's calculate as N1. N1 be the number of organisms in the 1000 decimeter cube vessel. So N1 is number of viable organisms start of sterilization. This is N1. Okay. So we can multiply it. You have to convert a decimeter into centimeter cube or vice versa. So what is the conversion factor? 10 power of for the answer. So this 10 power of 3 to 10 power of 10. So the probability of unsuccessful sterilization is given as 1 in 1000. So 1 in 1000 is 10 power of minus 3, right? So let's keep this as N2, which is number of viable cells at the end of sterilization. So del factor Kd into T is the del factor. You were asked this. So to calculate del factor, there is the formula which is what ln of your N1 divided by N2. So if you do this, what you will get ln of 10 power of 6, 10 power of 12, right? What would be the answer?
And can be calculated as log 10 power.
Karthikeyan, your Voice is breaking actually.
Ma'am, can we calculate it as ln 10 power 15, ma'am?
Yeah, you can. Yeah, sorry.
Whether it is 10 to the power minus 3, right, ma'am? 1 in 1000.
Yeah, it is 10. The above it is 10 power 12 and down it is 10 power minus 3.
Okay. 34.5, ma'am.
Yeah, it's 34.5. So the answer is your del value which is k into c is 34.5. So what is the next? The next question was you were asked to scale up and we have to determine the del factor for the same vessel considering the same. You just have to vary this volume and follow the same steps as before and you would be able to calculate the new del factor. So let's do that. So the N1 which is sorry, so your N1 in case of a 10 power of 10,000 decimeter cube reactor, right? So it is 10 power of 6 organisms per centimeter cube. So 10,000 decimeter cube and 6,000 conversion factor. So these things will cancel out. So your N2 which is 10 power of minus 3. Your del factor is 8 into 10. This is ln of N1 by N2. So then what you have to do? So we'll keep it as such.
Ma'am, it will be ln 10 power 16.
Yeah, we can keep it as 10 power 16. The ln of 10 power 16 is
36.8.
yeah, 46.8. So this is your del factor when you scale up your reactor.
Okay. Having a doubt on
Yeah.
how to solve in last
Hmm.
assignment.
What?
Last assignment.
Last
Assignments.
assignment? Ask.
Baseless stereo
Yeah. So
stereothermal.
your last question or last assignment?
Last assignment question.
So the solutions will be released soon. I hope by this week.
Okay.
Yeah. So in that you can check. So in our side, it's already in being processed. So you will be receiving the solutions.
Mm. Ma'am, can you read the question, ma'am?
Uh,
Previously, what you have got.
okay, you want to see which question?
Mm, yeah, this question.
Yeah. So this question is very simple. This question, I hope you remember the Arrhenius equation where your KD is AE minus E by RT, right? So I'll
Yes,
read the
ma'am.
question and check whether you are able to understand it. It's very simple only, so I'll read once. So you were asked to sterilize a batch media, which is 200 liter, and your probability of unsuccessful sterilization is given as 0.001. You were asked to ignore the heat up and cool down periods. And for Bacillus stereothermophilus, the spore concentration was given as 10 power of 8 spores per liter. Your E value is also given, which is 67.7 kilocalories per mole. And your A values is also given, which is 10 power of 36.2 minute inverse. Everything is given, including your gas constant. And you were asked to calculate the value of Kd in terms of R inverse. And your temperature is given as 121 degrees Celsius. So as everything is being already given, you just have to do the unit conversion here. Only one unit conversion or two will be there. You have to convert this 121 degrees Celsius to Kelvin. So 121 plus 273 Kelvin gives you 397, I guess, 397 Kelvin. So 121 plus 273, that's how you convert your degree to Celsius. And if you do that and keep, then it's fine. And the E values also is in kilocalories. So if you miss this kilocalories, you will be calculating just if you substitute 67.7, it will come in as an error. So 67.7 into 10 power of 3 instead of this K, which is which means kilocalories. So you are multiplying 10 power of 3. So if you do this simple conversions and substitute in the formula, you will get the answer. And then also you have to make sure to the answer will be in terms of minute inverse. You have to convert it back to R inverse. So should I solve this problem?
Yes, ma'am.
Yeah, let's start solving it again.
Since I made mistake in last assignment, this conversion, so I missed kilocalories as well as
Okay,
minute in, ma'am.
okay. So just be careful when you read the question, because when you are solving now, keep all the units in the same, so that unit also you write it and solve. If you write here how much the unit, then you will see whether they are cancelling down or not. From that, you can identify your mistakes.
Yes, ma'am.
Yeah, should we solve it?
Ma'am, one more doubt, ma'am.
Yeah,
Ma'am, whether here we are converting E by RT, right, ma'am? So we
only the value of E.
uh,
Yeah,
whether we have to take only the final temperature or we have to separate for 1 by T, 1 minus 1 by T. In
no,
terms
no,
we have
no,
to
no. No, as a whole only you have to take E by RT. It is a whole term.
okay, ma'am. We don't need to take that 0 degree in consideration, right?
No, no, no. E by RT as such you have to take.
Ma'am, whether we have to take that only one temperature, particular temperature.
So here the temperature given is 121, right?
Yes, ma'am.
Yeah, in your question, no other temperature is being given to you.
Okay, ma'am.
Yeah, that's why.
Assignment, that 0 degree Celsius, ma'am.
Yeah, so 0 degree Celsius is this is given for case of what you can tell. For conversion factors only they have given in 0 degree Celsius. There is no need to take this into account. So you were
Okay, ma'am.
asked
I
to
agree with that.
calculate at the temperature of 121 degrees Celsius, right? You were not asked to calculate at 0 degree Celsius.
Yes, ma'am.
Yeah, so read through your problem so that what has been asked you can understand it.
Yes, ma'am. Got it.
Yeah.
Ma'am, in case any doubts, can I mail it that assignment question?
I I'm not able to get you actually. Can you repeat
Please,
the question?
in case of any doubts, can I mail you?
Yeah, if you have any doubts in the live session, you can mail me at my mail ID actually. Let me put it in the, wait a minute. I will put it here.
Actually, we got doubt in assignment.
If you have any doubts in the assignment, you have to mail in the discussion forum actually.
Okay.
Yeah, this is my mail ID. You can mail for any questions regarding the live session. You can ask me here in this mail ID.
Okay.
Yeah,
Sure.
yeah. So, I think you are getting the link for the previous sessions, the live sessions. If you have not participated in that, there will be links provided, I guess. So you can go through that to check the previously solved problems.
Yes, ma'am. I didn't participate. Today I participated especially for clarifying in that
Okay,
assignment
okay.
question. So,
Yeah, it's fine.
uh, so in class, I think get the
Uh,
same answer what we, which is the result of the assignment answer. So after converting to our inverse also we get the same answer. So I get confused.
okay. So now your confusion is solved, or do you have the doubts still?
Yes, ma'am. Solved.
Okay,
So I'll try to solve that question.
okay.
Thank you.
Yeah, thank you.
What will be this previously solved links will be posted?
I think NPTEL is sending the mails, right? They have given the links for in your homepage itself. It will be there. I hope.
Okay.
Yeah.
I mean, whether this conversations, especially the special classes, right, now, this will be
Uh,
viewed or will
no, I'm
be.
not. I'm not able to hear you properly.
Can you hear me now?
Yeah, now I can hear, but in the middle it's breaking actually.
Okay. I think whether this session will be shared in terms of link or will be what they have taught earlier.
No, whatever taught in your lecture, the similar problems only I'm solving here. So
Okay.
this is
Whether
yeah, this is actually a doubt solving sessions only. So that lively you can participate in solving the problems. So these are all basic. The problems are all taken or in context with your lecture videos only.
okay, ma'am.
Yeah, so there is no difference that whether this will be or that will be. It is all the same. Similar kind of problems will be taught. Just that in case you guys have doubts while solving the problems, you can ask and clarify, right? That's why we are solving the problem live.
Okay.
Yeah,
Thank you.
yeah, it's okay. Thank you. So let's start solving the uh, question number 9, which is, let me read the question. So question number 9 is, a steam sterilizer is used to sterilize the liquid medium for fermentation. The initial concentration of contaminating organism is 10 power 8 per liter. 10 power of 8 organisms per liter. And for design purposes, the final acceptable level of contamination is usually taken to be 10 power of minus 3 cells. So this corresponds to a risk that one batch in 1,000 will remain contaminated even after the sterilization process is complete. For how long should 1 meter cube medium be treated if the temperature is 80 degrees Celsius, 121 degrees Celsius, 140 degrees Celsius? So to be safe, assume that the contaminants present are spores of Bacillus stereothermophilus, one of the most heat-resistant microorganism now. So for these spores, the activation energy for thermal death is 283 kilojoules gram mole inverse, and the Arrhenius constant is 10 power of 36.2 second inverse. Please take few minutes to read the problem, and we will be solving the problem soon. Um, so go through the problem, understand it. I hope you understand the theory behind this question. So at various temperature, you are asked to see how much time long it will take to sterilize the media, which is given, the given volume of media. So we'll take few minutes and then start solving the problem. So let's start solving the problem. So what are the given values? Your A value is given, your ED is given, it's 283 kilogram mole inverse. R is We know the R value, which is 8.314 joule Kelvin inverse, and temperatures are given, and the initial concentration of the contaminating organisms is also given. So, how long we should calculate 1 meter cube of media? So, 1 meter cube is 1000 liters, right? Okay, so we'll start solving the problem. You were asked how many, the time actually. So, you were asked to calculate the time to sterilize if the media is treated in these many temperatures. So what do we have to do? First we will do all the conversions and then start solving the problem. So we all know that so your specific death rate constant, which is Kd, can be calculated from your Arrhenius equation. Kd is equal to A power of minus E by RT. So we A value is given that you can write in joules to convert. So now you have to convert your temperatures into kelvins. So 80 degrees Celsius is equal to 80 plus 273. So we have just converted all these into Kelvin scale. So now you have to calculate your KD values. KD value for all these temperatures. So I start for A, which is 80 degrees Celsius or 353.15 Kelvin. What is the KD value? KD is 10 power of, we are substituting it actually. So 36.2 into e power of minus the value, which is 283, divided by R is 8.314 into 10 power of minus 3 into your temperature, which is 353.15 Kelvin. What would be the answer? KD at 80 degrees Celsius. What is the answer? So solve this and we will move ahead with the answers. So what will be the answer? Please solve it and tell me. Take few minutes to solve it. the answer. This I got around 2.2 into 10 power of minus 6 seconds. So similar way you answer is 2.2. So we should calculate it 121 degrees Celsius. So 10 power of 36.2. So please solve this and let me know the answer. So the answer for this is around 0.0497 meters. And what would be the answer for this? This answer is around 2.62. So now we have to calculate how much time it takes. So how do we do that? We have to use logical equation here. So the calculator, we have to keep the relationship between number of viable cells because that is the data given and time. How do we calculate that? You know the number of viable cells is 10 power of 8 cells per liter it is given. If you 1 liter is 10 power of minus 3 meter cube, right? So 10 power of 8 divided by 10 power of minus 3 meter cube, 10 power of 11 cells per meter cube, right? So this is your N naught. And your N, which is probability, is considered as 10 power of minus 3. So N is equal to N naught e power of minus E by k dt, whatever noun you substitute here, 10 power of minus 3 is equal to 10 power of 11 power of minus k d into t, power of k dt is given as 10 power of minus 14. So to remove the e, you are taking ln on both sides. So it would be what? K dt is equal to 30 minus k dt is equal to minus 32.24. So this your k dt is equal to 32.24. So you are relating it. So you are relating it to KD, right? So that is only 9 factor we have. So 32.24 divided by KD. So from this expression, you can start calculating for this individual temperatures which you have calculated. So if you do this, time at 80 degrees Celsius is equal to T is equal to 32.24 divided by your KD, which is 32.24 divided by 2.2 into 10 power of minus 6 second inverse, right? So that is the answer. So time at 121 degrees Celsius, 42.24 divided by 2.027 second inverse. Time at 141 degrees Celsius equal to 32.24 divided by 2.63 second inverse. So please calculate. So to convert it to hours, and we can keep it in seconds or we can convert it to hours. I'm converting it to hours, so 16 to 16 seconds. So if we do that, this answer is around 4.70 hours. So here, if we do this, how much it is? The answer is 32.24 divided by 0.04975. There's actually 648.04 seconds. Or you can write this divided by 60 to do. It's 10.8 minutes. And how much is this? 32.24 divided by 2.63, right? 2.63, which is 12.25 seconds. So, as a whole, if you calculate, it would take if at 80 degrees Celsius, it will take 4070 hours. At 121 degrees Celsius, to destroy that much of organisms, it will take only 10.8 minutes. And if you increase it to 141 degrees Celsius, it will take only 12.25 seconds. So, from this you can see it's always generally what is being preferred. It is a higher temperature, a short duration, right? So you can see how if you increase the temperature, how the duration to sterilize the given volume of media is getting decreased. So it's the last question. Please take few minutes to read the question. This is very similar to your previous problem, so that I guess you can solve it on your own. Still, we will solve. Please take few minutes to read the question. I would also read the question. So, our question number 10 is an article malfunctions and the temperature reaches only 119.5 degrees Celsius. So, the sterilization time at the maximum temperature was 20 minutes, and the jar or the vessel contains 10 liter of the complex medium that has 10 power of 5 spores per liter. So, at 121 degrees Celsius, the KD value is 1 meter inverse, minute inverse. So, and your ED value is 90 kilocal gram mole. So, what is the probability that the medium was sterile? So, you were given the value of 121 degrees Celsius only. So, we'll start solving in a few minutes. How do we start solving the problem? So if we solve for the given values while considering at 121 degrees Celsius it is. So how do we calculate? Your time is 20 minutes. So volume is 10 liters. Your spore count is 10 power of 5 spores per liter. So it is 10 power 6. Right? Similar to your previous first problem, your del factor is Kd into T, which is your Kd is Kd for 1 degree Celsius, 121 degree Celsius is 1 and into T, which is 20 minutes, is 20. So your P naught of T is equal to 1 minus a power of minus P dt N naught. So that would be the 1 minus a power of minus 20, 10 power of 6. This is one way. So this will give you your probability of successful sterilization. Successful sterilization. This is in case of your temperature is at 121 degrees Celsius given. So you have to find this answer. So, but the temperature has not even reached 120 degrees Celsius. It was reached only 119.5 degrees Celsius. So, if you convert it to Kelvin, 119.5 plus 273 is around 392.5. So, if you want to calculate the KD for 121 degrees Celsius is given as 1, right? For this, you can calculate the KD, which is E bar of minus E by RT, considering E is equal to 10 power 36.2, E is equal to 283, and R is what 8.314 into 10 power of minus 3 kilojoules. So if you substitute this and calculate, you will get a KD value. So that KD value is going to be obviously lesser than the KD value, which is going to be 1 as given as 120 degrees Celsius. And then if you solve like this, you will get the probability of successful sterilization. Compared statement you will be able to get. So what would be the answer for this? This answer is 0.9979. So the probability of death is approximately 1. So for this, the answer would be what? Try solving it. So you have to find the KD value, then solve. Try solving the same way as like this. So it would be KD at 119.5 degrees Celsius is 10 power of 36.2 into e power of minus 283 numbers divided by 8.314 into minus 3 kilojoules. Kelvin numbers into your temperature is what? So now solve it. Try solving it. Step by step we will solve. is KD. Sorry. We have to solve P naught T is equal to 1 minus e power of minus KDT into N naught. With this new KD, power of minus e power of minus, what is this? 0.0341. What is the answer? Into 20, right? Your time. So it would be e power of minus. That's the coming as 0. So the probability of successful sterilization is 0. So this would be the answer. So we are at the end of the session. I hope I was able to solve a few problems related to electricity. Next week we will be solving few problems related to scalar and non-ideal games. If you have any doubts, please reach out to the discussion forum mentioning it is from the live session conducted on the date, which is 17/3/2023. So this it will be easy for us to really helpful for us to answer the question if you mention the live session dates. Um, so if you have any doubts, you can contact in my mail ID also given in the message box. And um, so I hope the session was useful. Um, so thanks for participating in the session.